In this video, I will introduce the concept of a subset. I will first provide the definition. So for any two sets, A and B, we say that A is a subset of B if and only if every element of A is also an element of B. And if this is indeed the case, we use the symbol A is a subset of B to represent this idea. And so now I'm going to show you some examples on how we can apply this concept. For our first example, let's say A is the set consisting of the numbers 1 and 2. And let's say B is defined to be the set consisting of the numbers 1, 2, and 3. Now using the definition, I want to show that A is a subset of B. And in order to show this, I need to show that every element of A is also an element of B. And so we check each element in A, we see that 1 is an element of A, and incidentally it is also an element of B. And also we check that 2 is an element of A, and turns out it is also an element of B. And so you see that we've checked all the elements of A, and then we see that every single element in A is also an element in B. And so therefore by definition we can conclude that A is a subset of B. Let's take a look at another example. This time let's say A is defined to be the set consisting of the numbers 1, 2, and 4. And let's say B is defined to be the set consisting of the numbers 1, 2, and 3. This time we can show that A is not a subset of B by showing that it doesn't fit the definition. So you see that 4 is an element of A, but it is not an element of B. And so therefore it violates the definition, because if A is indeed a subset of B, then all elements in A must be an element in B also. But then we've just showed that there does exist an element of A that is not an element of B. And so that's why it violates the definition, and so that's why we can conclude that A is not a subset of B. Now before I end this video, I want to show you a graphical representation of the idea of a subset. So if A is a subset of B, we can understand this visually by drawing a circle. So let's say this circle represents the set B, and if A is a subset of B, then A can be represented by a circle that can be drawn inside the B circle. So you see this brings out the fact that every element in A is also in B. So the set B contains everything that's inside A as well. And so let's try to apply this idea to our previous examples. Going back to the first example, recall that set B is a set consisting of the numbers 1, 2, and 3. So we can draw a circle and then place the numbers 1, 2, and 3 inside. And then also note that set A is a set consisting of the numbers 1, 2. So we can draw this circle here to represent set A. And you can see that in this case, our set A circle can be contained entirely within the set B circle. And this would correspond to the case where A is a subset of B. Meanwhile, for the second example, recall that B also consists of the numbers 1, 2, and 3, so we can draw that as well. So B has the numbers 1, 2, and 3. Meanwhile, A consists of the numbers 1, 2, and 4, so we can draw the A circle like this. So A has 1, 2, and it also has 4. And you can see that I'm forced to draw the circle like this, and I cannot draw the A circle inside of the B circle because there is the 4 contained within the A circle. So if I draw this A circle inside of the B circle, then that would mean 4 is also inside B. But then we know that that's not the case. 4 is not an element of the set B. And so you see that I'm kind of forced to draw the circle like this. And so this will correspond to the case where A is not a subset of B, because I can't contain this circle inside of the B circle. And of course this is only one case of A not being a subset of B. Another case would be when the A-B circles are completely separated, and that would correspond to the case when there are no overlapping elements. And for this case we can also conclude that A is not a subset of B.